We are looking at the line of best fit. So, a line of best fit or trend line is a line on the graph showing the general direction that a group of points seem to follow. It's kind of like an estimated line that goes over the scatter plot. This line may pass through some of the points, none of the points, or all of the points. So it doesn't have to go through every single point because you want it to be a straight line. Here's some examples. So this first one, see how it goes through the point or through the points, but it only actually passes through one of them. Try to have the line as close as possible to all the points and as many points above the line as below. So if you look at this line, it goes through one point. It has 3 points above and 2 points below. The x-axis represents weeks. The y-axis represents number of cars washed. So this is actual data. So scatter plots come from gathering data from actual events that have happened. So they washed cars over 7 weeks and collected the data from that. The next one is a negative correlation. It's going downhill, so your line will go down. So it has a negative slope. This one is time spent on computers in minutes and time spent watching TV. So TV time versus computer time. This one shows a positive correlation. This one shows a negative correlation. So positive correlation will have a positive slope. Negative correlation will have a negative slope. Here's a non-example. Does this line graph look like a good line of best fit? No. It's terrible. Why is it so bad? Yeah, it's not even in the midst of the dots. So I'm going to put all of the points are above. But they're supposed to be above and below. Let's go ahead and draw a line of best fit on here. So get your ruler. And let's figure out where we should plot these. I would say these are kind of like outliers here. So we need to put it in the midst of this. And it's going to be an estimation. I think it should go perfectly with corners. I think there's too many above versus below. I'm going to move it up a little bit. Yeah, there are some outliers. So say something similar to that. It's not going to be perfect. We can use our calculator to find the perfect line, and we're going to do that tomorrow. But right now, we're doing an estimated line. Go to the next page. Look at the graph below with a line of best fit already drawn in. Answer the questions. So this is hours worked is our x-axis. Dollars earned is our y-axis. The title is earnings at work. How much did Jim earn for working 5 hours? On this question, it's asking where exactly the point is. How much did he earn? So what we do is we go to 5 hours and we find out where the corresponding point is. It'll be right here. So how much money is that? 48. 5 hours, $48. Use the line of fit to predict. So this one's predicting. So you're going to use the line to predict how much money Jim will earn for working 7 hours. So go to 7 hours, find the line, a little highlighter. So 7 hours. I'm going to go up and find out where it crosses. So we've got to do an estimation there. So I'm going to look at my y-axis. So in between is 56, or in between 56 and 64. So halfway between that would be 60. But it looks like it's a little below that. It's not quite 60, because 60 would be exactly half. So it looks like halfway between 60 and 56, actually. What's halfway between 60 and 56? So $58 for 7 hours. Now look at the next one. Use a line of fit to predict how many hours Jim should work to make $72. 72 would be right here. So you'd look at $72 because it says dollars earned. You go over, find out where it lands on the line. And it is exactly 10. So make sure to put 10 hours. Not $10. 10 hours because it says how many hours. Now let's look at the next one. Scatterplot below shows the relationship between the number of baseballs used in 14 games, the number of pitches thrown in these games. So we have pitches thrown, number of baseballs. Do y'all know what this little squiggly represents? It means we're skipping data or skipping anything from 0 to probably about 200, a little less than 50, 245 or something like that. So they didn't have any data between 0 and 245 or 250. So they just put this squiggly instead of doing a long blank area. So we're really starting at 250. It's based on the scatter plot, draw a line of best fit. So let's get out our ruler. Let's look and see what we could do. So here is below all the points. And this would be above all the points. So we want to go through the points and have as many above as there are below. So I'm going to turn my ruler like this to see if I can kind of. And yours isn't going to be exactly like mine, but it's going to be close. What do y'all think about that? Is that about even? Or should I move it up a little bit more? Maybe up a little bit more. I'm thinking too much. You're probably right. Something similar to that. It doesn't have to be perfect. Yep, that was my promise. Thinking too much. All right, so we drew a line of best fit. So now let's answer number 2. What is the best prediction of the number of baseballs that will be used if 275 pitches are thrown? So 275 pitches, so that's X. When X is 275, it's going to be halfway between. That would be 275. So go straight up. Find out where that would be located. About 100. So let's put that, about 100 baseballs. What is the best prediction of the pitches thrown if there were 130 baseballs used? So we're going to the number of baseball used now. So we're going to go to the y-axis, search for 130. So that'd be between 120 and 140, right there. I can actually use my ruler to go over and find out where it reaches on the line. So plot a point there. So what would that go down to? About 290? About 290 pitches thrown. I want you to answer the 3 questions on the other side now. So go ahead and do that. I'm going to give you a few minutes to do it quietly on your own. Let's look at the first one. Predict the grade of a student if they have 3.5 hours. It says draw a line of best fit for each of the graphs and answer the question. So what might actually help, because some of these lines of best fit are kind of hard to do. So what I'm going to have y'all do first is plot these points at 3.5. So 3.5 would be right here. We're going to plot the points and see which one falls within the rest of the points. So 3.5, 80 would be here. So I'm going to go ahead and label that A. 95 would be here. So it'd be B. 100 would be there. So it'd be C. And 90 would be D. They're all really close together, aren't they? Okay, so let's look. If you do your line through C, that kind of looks too steep. Halfway between what? Mm-hmm. I think C is too high. I think B is too high. So it's between A and D. So if it goes through A, it'd be like that. If it goes through D, it'd be more like that. I think D is a better prediction. Mine went through 2 points and had some above and some below. I think A is too low. Hopefully, other problems won't be as close as this because this was really close. Okay, I think D is the better pick there. A is a little too low. Okay, let's do the next one. Predict the grade of a student that has 7 absences. So 7 would be right here. So let's plot those points. So 7 at 30, 7 at 40. So let's see. A, B, 50, or 60. Which one falls within the data? If I ignore all of these, look at those. Yeah, it's 60. Tricky, right? Yeah, let's do the last one now. So you're looking for the point that looks the most disguised within the rest of the data points. You don't want an outlier. Now let's look at the last one. Based on the trend in the data, approximately how many free throws would a player be expected to make if he attempted 60 free throws? So let's look at 60 and let's plot these points and figure out which one is the most disguised. So 50, be up here, so that's A. B is 35. C is 25. D is 60. So which one looks most disguised within the data? Where is 50? 50 is up here. Which one's, I would say B. B is more within the rest of the dot. They are tricky. I'll tell you that. Okay, so go ahead and glue this in your journal, and then your assignment is on Delta Math.